Hello boys and girls, welcome to Mrs. Bandu's Math Boobies. This is lesson 6.5 for algebra, point-slope form, and writing linear equations. Our objectives are to graph and write linear equations using point-slope form and to write linear equations using data. Okay. The point-slope form of a linear equation of a non-vertical line that passes through point x1, y1 with slope m is y minus y sub 1 is equal to m times the quantity x minus x sub 1. Okay, so basically what we're looking at is dealing with a certain point and our slope as well. So that's why it's called, clearly then, the point-slope form. As I mentioned in class before, all three of these forms are related. Different methods lend themselves well to different applications. So first off, this is just a quick review of our three linear equations. Remember, the slope-intercept form is y equals mx plus b, where m is the slope and y is the intercept. Standard form, ax plus by equals c, where a and b are not both 0. Okay. In this format, we look for the intercepts, the x-intercept and the y-intercept, use those for graphing. Back to slope-intercept, we use the y-intercept and the slope to accomplish graphing. Now, here we have point-slope form. X sub 1, y sub 1 lies on the graph of the equation, and m is the slope. So this is any random point on the equation. So y minus y sub 1 is equal to m times the quantity x minus x sub 1. So your equation is going to look something like this. If the point that we looked at was 1, 1, and the slope is negative 2/3, we have y minus 1 equals negative 2/3 times the quantity x minus 1. Okay. So those are the three different formats, and we'll look at how we might use them. Okay. All right. My screen is really small on my computer. It's kind of making me crazy here. Sorry. All right, so graphing using point-slope. We want to graph the equation y equals y minus 2 equals 1/3 times the quantity x minus 1. The equation shows that the line passes through the point 1, 2 with slope at 1/3. So we're going to start at the point 1, 2. And using slope, we're going to go up 1 unit and right 3 units. Okay. And let me look here. Okay, so 1, 2. So here's 1, 1, 2. And then our next point, we're going to go up 1 and right 3. So up 1, 1, 2, 3. And that gives me the ordered pair 4, 3. Okay, and now you can draw the line through the 2 points. Okay, see my trusty ID right here. So again, you can take your point. Remember, this is going to be your x, this is going to be your y, so your ordered pair is 1, 2. So you're going to start at the point that you know. Using slope, you're going to find a second point, and then you'll have enough information to graph a line. Okay, write the equation of the line with slope negative 2 that passes through the point 3, negative 3. Okay, so here is just our simple point-slope form. X sub 1 is 3, y sub 1 is negative 3. So this is going to be y minus negative 3 equals the slope of negative 2 times the quantity x minus x sub 1, and x sub 1 is going to be 3. So basically we substituted negative 3 for x sub 1, y sub 1, and negative 2 for the slope. That's all that's asking me right there. Now basically that means we're going to do y plus 3, because minus negative 3 gives you plus 3, equals negative 2 times the quantity x minus 3. So the equation is y plus 3 equals negative 2 times the quantity x minus 3 in slope-intercept form. Okay, so again, it's just a manipulation of the form of the line, of an equation of a line, and in this one, again, we know a point on the line, and we know the slope, and then from that point, we can figure out another point to help us move on. Okay, now let's go using 2 points to write an equation. Example number 3. It says write the equation for the line in point-slope form and in slope-intercept form. Okay, now we need the 2 points here to figure out the slope. We'll do it mathematically. If you already have a graph, remember you can do it by counting as well. But my two ordered pairs are negative 1, 4 and 2, 3. Okay, so I'm just going to jot those down there so I don't lose them. They're right here as well. And we'll call this x sub 2, y sub 2, x sub 1, y sub 1. Again, totally arbitrary. Okay, so I'm going to do 4 minus 3, x sub 2 minus, y sub 2 minus y sub 1. And then on the bottom, I'm going to have negative 1 minus 2. Okay, so 4 minus 3 is 1. Negative 1 minus 2 is negative 3, so the slope is negative 1/3. And you could verify that here. You're going to go down 1, right 3, negative 1/3. So you can double check yourself, because I do have a graph. Now I can use either point to write the equation in point-slope form. So since they've set up our example for us, they've asked us to use negative 1, 4. If you are doing this on your own, you have that choice. So I'm going to substitute in, this is going to be y minus 4 is equal to negative 1/3, the slope that I found up here, times the quantity x minus negative 1. So this is going to be y minus 4 equals negative 1/3 times the quantity x plus 1. I'm going to simplify minus negative to plus 1. Okay. Rewrite the equation from step 2 in slope-intercept form. So what this means is I'm going to actually have to do just a little bit of math here. Okay, so I'm going to fill in from right up here. Y minus 4 equals negative 1/3 times the quantity x plus 1. Okay, so now what I'm going to do is I'm going to add 4 to each side. Well, actually, I'm going to distribute, my bad. Negative 1/3 x and minus 1/3. Okay, now to remember, slope-intercept is y equals mx plus b. So I'm going to add 4 to each side. Wish they'd leave a little more room, but they don't always do that for us. So what that will leave me with is y is equal to negative 1/3 x, and then negative 1/3 plus positive 4 is going to be plus, oh, I'm sorry, minus, actually that's going to be plus, 3 2/3. as I'm adding 4. Okay? So there's that. You do have a couple of quick checks here. And there's a lot of numbers going on here, so you might want to just pause the video at some point and just sort of process all this information. I'm spitting out a lot of information to you, and you might want to just look over it. Be sure you're grasping everything. And as always, if something doesn't seem right or you catch a mistake of mine, please definitely bring it into class so that we can discuss and correct as needed. Okay, writing an equation using a table. Is the relationship shown by the data linear? If so, model the data with an equation. Okay, so remember what we want to do is we want to find the rate of change for the consecutive ordered pairs. Okay, so what I'm going to do here is the change in y over the change in x. So here are my changes in x. I'm going to figure out my changes in y. So 6 minus 4 is 2. Let's see. 4 minus 2, or 4 minus 6, excuse me, gives me negative 2. 6 minus 2 gives me 4. Negative 2 minus 4 gives me negative 6. Okay, so those are my numbers there. I'm going to now fill them up. The change in y, which is negative 2, over the change in 1 gives me a 2. The change in y over here is negative 6. Its corresponding change in x is negative 3, so that simplifies to 2. Here, from negative 2 to negative 6, I'm going to subtract 4, so the change is negative 4. Here, the change is negative 2 for x, so again, that simplifies to 4. So the relationship is linear, and the rate of change is 2. Okay, so again, I just figured out what do I have to add to 6 to get 4. I had to add negative 2, and so on. Okay. Use the slope and a point to write the equation. Okay, so the slope we found is, 2. So I'm going to fill that in right there, and right there. And I'm just going to pick the ordered pair, 3, 6. I'm just going to pick the top one. You can choose any one that you want, by the way. So y minus 6 equals 2 times the quantity x minus 3 is one of my possible equations. Okay, there are others, again, depending on the ordered pair that you choose. Again, in class, if you want to ask more questions or you've chosen a different point, double check with me that everything is okay. All right, let me double check. Okay, I think that's the last one. So you have a couple of more quick checks. Please have these ready.